What's up, guys? I know it's been a couple weeks since I've uploaded a video. I had a few videos built up, but I got extremely busy with a lot of different things and exhausted that catalog of videos, so I'm kind of trying to catch up here. I have so many videos recorded, just getting the time to edit it has been impossible lately, and I've got a stack of parts ready to go on the side-by-sides, but I mean, I just haven't been able to get out. I mean, look at the dust on this thing. It's so sad. I actually missed a Twisted UTVs ride. I was really bummed about that. I've had just a lot of things going on in my life. I recently just started a new job, and I've been getting things ready for that. I had to go through the interview process, and there was a lot of research I did on the company and all this stuff, and made sure that I wanted to make the switch to this company. And so far, I'm absolutely loving the job. Also, I've been doing so much stuff around the house, trying to get, just the spring stuff done. I've got 3 decks on my house and been redoing all those, and it has been miserable and just power washing the house. And then, unfortunately, my uncle passed away, and 2 different weekends we had a memorial for him. And I'm really close with him and his family, so I wanted to be at both of those. So I was unable to make the ride. And then other than that, I mean, I've had so many side projects going on. The CNC plasma table, since I've got that running, I've been making parts, and I'm actually getting quite good at it, actually. And I've been trying to maybe develop a LLC where I can do some. Ideally, I'd like to get into making fixtures and things, because that's what I really enjoy designing. I've designed interior car parts, medical devices, but the fixtures, I really enjoy that. It's pretty easy work. I can design a lot of it out of flat stock that I can cut. I got a lathe, working on getting a mill, maybe a CNC mill, trying to get power in the barn. So I've had a lot going on there. I bought a sheet metal brake, just trying to get a good fabrication shop set up, so if I do this LLC thing, I can get it going. I'm thinking about making some side-by-side parts. I don't know if anybody would actually be interested in them, but they're stuff that I wanted for myself. I designed and cut up a new Rhino door pad mount. I cut this with the CNC plasma cutter. The Rhino door pad replaces your stock shoulder pad here with just a Yamaha Rhino door pad. I made a video on it. I kind of welded up a crude version of this, but I finally finalized it. I got some rib nuts in it, and this thing fits up perfect now. It just mounts to the back of your Rhino door pad, and then you just drill the 2 holes in your door latch here to mount it. But I got that design perfected, and I got a couple buddies that wanted some. If anybody wants some, get a hold of me. I can whip some up. I actually bought a powder coating gun. I bought an oven, just a regular kitchen oven, but I haven't got it wired in. So right now I'm using a toaster oven to cure the powder coat, but it's coming out really nice. I'm really happy with the results here. Some other little things that I've been making. This is trademarked, but I just made it for a friend. Jeep keychains. That's just something that I cut out with the plasma cutter. I thought it was kind of neat, just using up some extra material, that was going to be scrapped anyway. I developed a pretty good barn star pattern that I can scale up and down so I can make stars. This one's a prototype. It's in really rough shape, but yeah, it's got spot welds that don't look too good, and it's not painted or anything. But yeah, I've just been playing around with the plasma cutter. In this video, I'm gonna unbox and assemble my CNC plasma table. I'm gonna wire up the plasma cutter so it works with the table. I mean, I'm gonna show you what software you need to install to, produce things on the table, and just show you how it cuts and everything. This is not exactly, side-by-side related, but I'm gonna be making a ton of side-by-side parts with it, so I figured I'd do a video on it. I did format this as kind of a step-by-step, assembly, so feel free to skip through, or you can pass up this video if it's not your thing. But I tried to get very in-depth with it, so if somebody's putting it together and they run into any of the things that I ran into, this video can help them out. The CNC plasma table I chose is one of the more affordable options, but it's also really well made. I did a lot of research into the table because it's a big investment. I made sure that there was a lot of information, you know, to help me out since I'm just getting into all this. There's a forum where there's a lot of helpful information and people to help, and I mean, I had a lot of luck with getting this thing set up. A lot of people helped me out. I also made sure that the programs and software that you use with the table were easy to use and intuitive, because I didn't want to struggle through it. You know, I just wanted something easy. I can make some parts, fit them up, and be done with it. So I think the option I chose was a great option. The table I chose is the Langmuir Crossfire Pro. I'll give you the table size right here. I wanted the 4x8 table, but at the same time, I don't have a ton of room in my shop, and I was thinking of all the stuff I'm gonna make. None of it's giant, and I can also slide the plate and cut portions at a time, so really, you know, I can do a lot with this table. And I mean, the table was like $2,700, and then add tax, and then so that's like almost $3,000. But then you got to buy the torch height controller, which is a module that controls the tip of the torch. So if there's any warp on the piece of metal, it adapts to that, so you get an even cut. I would definitely recommend that. It's a little more work to set up, but it works super well. I don't know what it's like to not have one, but I know a lot of the thinner materials, like the stuff that I cut those stars out of, it bends a lot, and I'm really glad I opted for the torch height controller. It's an extra $400, but I think it's worth it. One of the reasons I bought a CNC plasma table was because I have a giant Lincoln ProCut 80 plasma cutter. I bought it from Michigan Speedway, where I used to work quite a few years back now, and I had planned on using that plasma cutter. I got it all wired in and everything and did a little bit more research, and it's got a high frequency start, kind of. This table says do not use a plasma cutter with a high frequency start. So I didn't realize that until I bought the table and assembled it. So I was kind of stuck there. So I ended up, you know, I think the ProCut 80 would have worked, but I didn't want to chance it. I didn't want to fry something in the table. So, and the plasma cutter was quite a few years old, so I figure newer technology will probably cut better anyway. So I bought a HYPOTHERM 45 plasma cutter, brand new. That cost me about $2,000. So I mean, to buy the plasma cutter and the table, I got probably $5,200 into it, which is definitely a big investment. So I'm hoping to make some parts, make some money back, make, you know, signs, stuff to sell. I don't even know, but I really enjoy doing the cutting, so it's going to be a good time anyway. But when you're buying a plasma cutter, you really got to think of all the other stuff you need. Like the plasma cutter takes a 220 plug, and then my air compressor takes a 220 plug. Well, I got one 220 plug in my barn, so I have to get it rewired so I have two outlets. Also, you have to make sure your air compressor is big enough to supply air to the plasma cutter, otherwise it'll shut off with low PSI. And I think it was 6 CFM that you gotta have in order to run most plasma cutters. So I had to get a bigger air compressor. So I mean, it's a big investment, but it's a lot of fun too. So let's start tearing into these boxes and getting it assembled. All right, this box says hardware. Oh wow. Man, why is everything I buy just a ton of work? Some spacers, pipe fittings. Some of this stuff is pretty foreign to me, to be honest. Washers, some self-tappers. That's always a good sign. All the bolts. Some nuts. I did opt for the torch height controller. It was a $400 add-on. There's some wiring, some more wiring. Looks like a chip of some sort. Maybe it's like an eye, like a photo eye. I really don't know. I can't say that it is. And then a controller box and some Velcro. Looks like 400 bucks to me. JK. Hopefully it works good. All right, this box here says stepper motors. Oh, nice. Those are pretty nice motors. Yep, looks like just the motors and the wiring. All right, that's not as overwhelming as I thought it was gonna look. All right, this one here says miscellaneous. So it's a surprise. Oh, nice. Some hopefully instructions, because oh, it's got a serial number to put on it. 2 pages in these instructions, so yeah. Oh good, there's a SKU to take a picture of, and it's a QR code. It'll take you right to the website for the assembly video. That's gonna be super helpful. Actually, I don't know if it's a video. It says instructions. Hopefully a video, because reading through all those instructions would be rough. Looks like we got power cable, some sort of plug, some bracketry, silicone. Looks like some cups. Maybe those are the feet. I'm not really sure. Maybe these are the feet. You know what? I'm gonna quit guessing. I don't know what these are. Caster insert. Let's see what else we got. Ooh, these are the torch holders. Looks like it comes with quite a few for different options. This looks like a printer plug here. Okay, we got a bunch of plastic end caps. And, holy crap, these are heavy. These are plates or blocks of some sort. Yeah, just a bunch of plates. Cool. We got these. Some bracketry again. Pretty nice welds on it. It's a unique piece. I'm guessing this is the same. Yep. cables. That thing looks complex. It's got a little cart that moves. Cool. And here's a little bracket with some bearings on it. It's light aluminum. Here's some carriages with some more bearings on them. They got a mounting plate. So we got, I think, 4 of these. That anodized looks really sweet. It's cool they put their logo on it. 2 more of these. Man, I don't know what any of these parts are. I might as well be assembling a spaceship right now. All right, this box says electronics. Oh, nice. Some washers. This is like the controls module. Can't get it in the frame. So this is like the controls module. It's got all the plugs and everything. Man, that's really sweet. These panels here, the 2 silver ones, those are the water table. And then these other brackets, I'm not exactly sure what those are for yet. Ton of square tubing. All right, I printed off the instructions and oh man, it's 77 pages. That looks like a lot of work. Let's get going. The first step is to put the adjusters on the legs. So it shows like a block like this. I couldn't find anything that looked like that. I'm assuming it's these. They just did a simplified representation of this. So it fits in there, so I'm gonna go ahead and pound it in and hope that's the right piece. So it's called leveling foot insert. You also need the bag 14, which is these nuts. Got him! And bag 4-1, which is these bolts here, and then these leveling feet cups. Take a bolt, and it looks like 2 nuts. And then you put the bolt through the foot here, put 1 nut down here, got a little burr there. I'm going to put the second nut on here. I'm going to put that one all the way to the bottom and then do my adjusting from there. I'll throw this in. All right, you're going to want to make sure that you're installing the foot on the side that doesn't have all the holes. I'm gonna go ahead and do the other 3 feet. All right, I got all the feet on from step 1. Now in step 2, it looks like we're assembling pretty much all the black square tubing. For this, we're gonna need this bag number 4 bolts, bag 13 nuts, bag 1 bolts, and bag 29 tube spacers. All right, so I'll get that together. It says they're 9/16 sockets. I haven't tried it, but that's what the instructions say. So that's what I got. I'm gonna lay out the top of the table first. So there's this left-hand lower rail and right-hand lower rail. And in the instructions, it shows you how to lay them out to determine which one's left hand, which one's right hand. I ended up laying them out and then marking left hand and right hand on them. That side's flipped over. So I got the left hand, right hand, and then the crossbars. I made sure I got my logos pointed the right way. Now I'm gonna grab some of these tube spacers here, start putting those in, start putting the bolts in. All right, I squared this frame up. I had to loosen and tighten this a bunch of different times. I just used a carpenter square in these corners to make sure they were all 90 degrees. The most important thing is to measure between these two tubes and make sure you have the exact same measurement. Make sure these tubes are parallel. Now we're gonna assemble this carriage here. So I have this bracket, and then I'll grab one of these carriages, line it up there. So I'm using bag 7 bolts, bag 19 washers, and bag 16 flange nuts. I'm gonna just loosely finger tighten these nuts on and leave everything loose. And then once I get this on its guide tube, so both carriages line up perfectly, then I'll tighten them down. It says to orient the carriage, so these adjustable set screws here are on the top and the side that has the longer flange off of it. All right, so I'm gonna grab these rails, and it says this hole goes over the back here, because that's where the cables go through. Set the other one up. I'll double check that I have the right orientation here. All right, when I set these on, I didn't actually have the right orientation. So this one on the back left has the hole there. It says it's for the cable support tube, but then on the other side, it's showing the large hole in the front. So I had to swap this one around. All right, now I'm gonna put these plates up that hold up that guide tube. So we have all these plates, the bolts from bag 3, the nuts from bag 13, and the washers from bag 20. All right, I'm gonna throw the plates on the bottom first. These 2 holes go up towards the top. And then the same thing on the other side. Put the washers on. Do the same thing on the back here. All right, now we'll lift the top up. Put one of these bolts in. I want to go back here. All right, now I'm going to take this nut off. I'll pull the bolt out. So we gotta put the carriage on. There we go. Throw a nut back in. Oh yeah. All right, I got the other side thrown together. So now both carriages are on. See what the next step is. All right, now I'm gonna start putting together this torch height assembly. It's got these V blocks here. I'm not sure if that's the right mount for my torch, but so I'm gonna grab this torch mount and then put this bottom V block on here. So it's a really tight fit, so you gotta kind of slide it and put it in there. And then I'm using these socket head cap screws from bag 8. I'm gonna use the bolts from bag 7-2. Put this on. Now I'm gonna throw this X-axis lead nut mount on this angle carriage. We're gonna use the bag 9 bolts again. Now we'll put this carriage assembly behind this Z-axis assembly, and we're gonna use these bolts here from bag 7. All right, so that's on there. All right, now it's time to mount this torch mount. It uses this strap and then a jam nut from bag 16-1 and then just a bolt from bag 7 again. So we'll throw the bolt through and the jam nut. I'm not exactly sure what the jam nut's doing. I think it just lets you adjust the thickness here. So we'll put that in the slot. And then I'm gonna use this knob here. It's like a quick release thread. Okay. Back that off a little bit. My jam nut. All right, I've set this gantry tube up here across these carriages that it rolls on. Now I'm gonna slide this Z-axis carriage on here, just like that. So the instructions say on this left side here is gonna be an X-axis motor mount. So we're gonna try to put it in here. You gotta kind of fish these nuts or bolts through. I'm not going to tighten them up all the way. All right, on this right side, we have this bearing block here. That's going to go on the right with the counter bore for the bearing towards the outside. All right, so now I'll make sure this and the motor mount are parallel, and then I'll snug them up. All right, now it's time to bolt this gantry rail down. So I'm gonna use the bolts from bag 2, the washers from bag 20, nuts from bag 13, and the tube spacers from bag 29. So this is a little bit different from the legs. These are gonna go in your tube spacers without a washer on it. Let's see if I can tilt this up. Put them in there like that. Now we'll throw a washer on the bottom and then a nut. I'm just gonna finger tighten these as well. I'm gonna get one in the other side because this thing constantly wants to roll with the weight of this assembly on the front. All right, now it's time to adjust these carriages in so everything's tight. So the instructions say to back off these bolts here by about a quarter turn, just in these two with the set screw coming out of them. So adjust those out a quarter turn and then tighten these set screws in until one or both of the bearings touch. So this eliminates the play within the carriage. So it looks like about right there. And then try this one. All right, so it looks pretty good right there. I didn't tighten them too much. Now I'll tighten these back up. Apparently they were looser than a quarter turn from the factory. All right, now that I got these carriages adjusted in, I'm gonna go ahead and tighten up these bolts on here. All right, now it says to push this gantry all the way to the front where these bearings touch this plate. I've put some pressure on it, so now they should be pretty lined up. Since most of these bolts are loose, we're gonna start by tightening these gantry rail bolts first. I'm gonna try to keep it snugged up to the plates here. Now we can go ahead and tighten up these bolts here. All right, it doesn't say to in the instructions, but I'm gonna roll this back before I tighten up the back ones. Just like up the line a little bit. There we go. Now it says to cycle it. Slides pretty good. I'm going to start throwing the water table on there. All right, so this part is one part where I think it's a little bit chintzy, to be honest. I would have really liked to see this water tray be one single piece instead of putting a seam in there. That's just asking for a leak. I mean, I know shipping and packaging, they had to, you know, do what they could to make it as small as possible, so shipping costs were down, but man, I really don't like that there's a seam there. But they do give you some sealant, and then all these bolts, we got to use bolt bag 11, bag 18 for the washers, and bag 15 for the nuts. They say to put a bead of sealant all the way around this lip where the trays go together, but they also say they'd put some sealant on their welded areas. It says it's been tested, but just to be safe, put sealant on the welded areas. I'm gonna start bolting it together. I really had to scrape through my toolboxes to find the right wrenches for this. This is a 11/32 socket and a 9/64 hex key. There's some pretty tiny bolts. All right, so there's gonna be a washer on each side. So I'll try to line these up. I don't wanna move around too much. I'll put one in this end first. So I got a washer on the head. And then I'll put a washer before the nut here. All right, now I'm gonna throw these drain plugs in. Here's the drain, and then it's got the actual pipe plug in there. And then there's some seals, and then some thin nuts. So I'll grab a drain, throw a seal on it. Throw this here. Hopefully you don't have T-Rex arms, because this is a long reach. All right, luckily I have this giant socket. Tighten it up. I just snugged it up a little bit. All right, now I'll throw a pipe plug in the bottom of it. All right, I just finger tightened it for now, but I will go back and tighten it up right after this. I am gonna throw a little bit of plumber's tape on these pipe plugs, just so they don't drip. All right, now we got this bag 21 with some self-tappers with some rubber seals on them. I tried to center the table as good as I could, and then it's about 1 inch overhang on each side. So that's how I lined it up. I'm gonna make sure I'm gonna set my impact real low, because I don't want to strip these out. I want it to seal really well. Maybe a little higher than that. All right, now it's time to put in the slats. I'm gonna put in these slat holders. I don't know exactly where they go. I'm gonna throw them over the self-tappers. All right, I got some slats. I'm gonna try throwing those in. Oh yeah, that's easy. All right, for this next part, we're gonna have to take this torch holder off. All right, so I'm gonna line this up on top of one of these slats. I did go around and tap each one of these slats in with a rubber hammer just to make sure they're seated properly. So I'm gonna use a square and then just check to see that this is perfectly perpendicular to the table. It's quite a bit off, so we're gonna have to adjust it back here. All right, I'm gonna keep tightening one of these 2 set screws until it's pretty close to perpendicular. So about right there. All right, I'm just gonna tighten this one up until the bearing just barely touches and doesn't roll anymore. So it looks like about right there. Yep. All right, on the bottom here, we're gonna tighten these 2 up. Same thing, tighten it till the bearing just touches a little bit so it won't turn freely anymore. There we go. There. All right, that's stable now. All right, I'm gonna grab this Y-axis bearing mount and some of these bearings out of bag 28. Just throw the bearing in there. Like that. That's a nice fit. All right, now I'm gonna grab 2 of these bolts out of bag 11 and just thread them in here. I think they just hold in the bearing. Next step is to secure the Y-axis screw bearing mount to the left-hand Y-axis rail with 2 of these bolts from bag 7. Now we'll throw the Y-axis screw bearing mount on this front left-hand side. They said you could take this bolt out to get clearance for these, to put these bolts in, but I'm gonna try it without. All right, I'll tighten them up. All right, I just snugged it up. It's still got a little bit of movement in it, but I wanna have some flexibility when I put in that screw shaft. All right, we're gonna do a similar thing on the back here. This is the Y-axis motor mount. It's gonna go on the back left-hand side. Gonna try to sneak those bolts in again. I'm gonna do the same thing, just lightly snug it up. Now we're just gonna do the same thing for the right-hand side. All right, now it's time to put in these lead nuts in the Y-axis. We're gonna use bag 18 washers, bag 5 bolts, bag 15 nuts. It's the 2 lead nuts that have the 4 holes. There is one in here with 2 holes. All right, I put the bolts with the washers on them. I'm gonna try to line them up with these holes. I don't know. Yep, just like that. I'll put the washers on the back. All right, now I'll do the same thing on the other side. All right, now we're gonna put on the X-axis lead nut. We're gonna use the last 2 bolts in bag 5, the last washers in bag 18, and then the last lock nuts in bag 15. Now we're gonna put on the X-axis lead nut. There, I left it a little loose still. We're gonna install the Y-axis lead screws. I'm kind of nervous about this. I had a bad experience with taking a Bridgeport apart and the worm gear in that, so a bit nervous here. But It says to start with the end that has the tapped hole in it. I'm gonna feed it through the motor mount hole and then feed it through here. It says to compress this white cap while you're screwing it in. All right, I'll keep feeding it through. You're supposed to have this gantry in the center and keep feeding it through until you can get this end here into that bearing. Okay, now we need a bag 17 washer and a bag 9 bolt. Now that I've got this threaded all the way up here, we're gonna put a washer on this. Put the bolt in there. All right, we're gonna put this other lead screw in. Since this thing takes forever to screw in, I'm gonna put a drill on the end of it. Screw it in most of the way. It's a lot less work. I'm gonna put the X-axis screw drive in. This one's a little bit thicker than the Y-axis screws. Once again, you want to center the head in the middle of the X-axis. All right, I'm going to put the bearing in here, throw the bolts in. All right, there's 3 of the same stepper motors, but 2 of them have short cables, 1 has a long cable. So the Y-axis takes a short and a long, and then the X-axis takes a short cable. To attach the motor to the drive screw, you use this coupler, and then there's 4 bolts. These are from bag number 8. Those are gonna attach the motor to the motor mount. So I'm going to go ahead and snug those up. These are some tiny bolts. Okay. I put the short stepper motor cord over there because I'm going to have the control box on the back left here. So I'm going to put the longer one over on this side. Slip my coupler on. Now I'm going to do the X-axis. I'll throw a collar on. Try to line up the holes. There. All right, now I'm gonna put these gussets up here. They're self-tapped in. I'm gonna use the bag 23 sheet metal self-tappers. All right, now I gotta take the cover off of this control box so I can put the mounting screws in. I'm going to take these sheet metal screws from bag number 22. They have like a plastic washer on them. And then this insulator insert. I'm gonna put the insulator on the outside. I'm gonna put the sheet metal screws through here. All right, luckily there's 3 pre-drilled holes here, so you can line them up. All right, I'm gonna put the cover on, but I'm only gonna put a few bolts in it. I just wanna keep some dust out of it. I think I gotta get back into this panel to wire in the height controller. So I'm just gonna run a few in. Now it's time to put all these caps in the ends of the square tubes. Just gonna use a rubber mallet. All right, I'm gonna put in this pole here. It holds the wires up while the head moves around. I'm gonna put it into these holes. It doesn't really say to put any fasteners in it. I got these 2 Velcro straps. One goes in the very end, which I probably should have done while it wasn't in there. I took it off. I'll put one in the end. Yeah, no way I would have got that. Seems pretty good. All right, I got the strap on the tip.
Try it again.
All right, I put the cable strap on the very end hole. Now it says to put the next one on the 3rd hole down from the top, which would be this one on the other side of the elbow. All right, got the next strap in. I'll put the bar back in here. All right, now we gotta run this wire up. I'm gonna move it. Oh, I can't move it to its. I'm gonna leave a little slack. I was gonna move it to the furthest position, but I can't really move it now that the motor's connected. I'm not gonna worry about tightening it too much right now because I know the torch wires and everything probably have to go on there. Now I'm gonna plug in the Y1 stepper motor. Y1 axis motor. Nope, give you a ton of extra cable here. Now I'm gonna plug in the X motor cable. All right, now I gotta run the cord to the Y2 stepper motor. I'm gonna use these P-clamps and some self-tappers just to run it along the back side. All right, now I'll plug it into the Y2 axis plug. All right, now I'll run the Z height controller. Plug it in here. All right, next it says to connect the IHS cable, which looks like this. It says it doesn't matter which plug this goes into on your Z height controller. Red and black can be swapped around, but I'm gonna try to do it exactly like they have it here. In the instructions, they had the black on the left, so that's what I'm gonna do. Now we will put this cable up with the motor cable. Now we'll run this and plug it into the IHS port. There's a little flange here. I'm gonna try to line that up. You can't plug this in the wrong way because it does have that flange, but try to make it easier. Now I'm gonna plug in the power cord and then the USB cord. The USB cord is gonna go to your computer. All right, to open this thing up, I loosened these two screws here, which were Phillips screws. Now I gotta flip it over. There's some Torx bolts on the underside. All right, here's the underside. There's one T30 and there's the other one. So I opened this plug up and I tested all the terminals inside, and I found that the torch control terminals are the orange and purple, which is what I found in a lot of videos in researching how to do this. So I just wanted to double check my machine was the orange and purple wires that control the torch. All right, I followed these torch wires. They go in and then over here to this cable here that plugs into the circuit board. There's enough wire. I'm just gonna peel back some of this so I can get to the purple and orange wire. And then I'm gonna use these splice connectors and splice into here so I have my torch power. I'm gonna be using this harness here. These connectors go to your splices, and then this connector here goes into your plasma table control box. All right, I've got my crimp connector on the purple line and the orange line. So now I'm gonna plug these connectors in. It doesn't matter which one goes to which. I got these splices on the orange and the purple wire. I had to use the blue because these wires are smaller. And I've got these connectors hooked up to the splices. Now I'm gonna grab this end here that goes into the controller of the CNC plasma cutter. I'm just gonna stick a probe inside, stick a probe here, and I'm using this multimeter from Harbor Freight. I'm using the resistance setting on the lowest resistance. And then we're gonna click the trigger button and watch the resistance jump up. So that verifies that we got the right wires. All right, I pulled this plug out of the front here. It was just a plastic plug. Now I'm gonna route the torch control cables through that hole. I'm doing this in my living room because it is like 20-some degrees outside. I really didn't want to be cold in the barn. My wife loves it when I work inside. Now I'm gonna run the torch height controller bolts. Those bolts will go right here in the HYPOTHERM 45. There's a negative and then there's a positive that says raw arc voltage. So it said that it came with these screws, but I did not see any of these screws. So I went to the hardware and picked some up. They're just an M3 screw. And I got some eyelets that fit on here. So I can just put the eyelet around the screw. All right, I got these banana clip plugs wired in. So the black goes on the negative, red goes on the positive. In the THC controller, the red is the clamp, which is positive. Black is the torch, which is negative. I'm gonna double check and make sure they're going to the correct things. I'll route these cords through the front hole here. I did put some wiring loom here so they don't wear on the edge of this hole. All right, I ran the torch height controllers down and then up to the hole. Then I ran these torch controls out and up and over and out the hole. I replaced the factory dust shield. Now we're gonna get it all back together. I'm gonna make sure this goes on that tab. So the torch is supposed to be black. So we will grab the black wire. So I put one probe in the black wire, and then I'm gonna probe the other side, and it's reading there. So when I have it off, nothing. When I touch it, it's reading. So that's definitely the torch. Now we'll test the clamp. So it says the clamp is red, so we'll do the same thing. So I got the probe in there, and then I'll just touch the clamp. So that's reading. That's good. Okay, so we got them on the right terminals. Now we'll plug them into the box and get the box Velcroed to the side of the plasma cutter. Okay, I will put it like that. Perfect. All right, I got to take the cover off this control box here. All right, my lighting's not really great here, but you can see down here it says pin D13. So in the instructions it says to locate pin D13 and then align up D13 on this THC control board here and plug this control board into this one here. So we'll open this one up. All right, here's the control board. You can see D13 there. I'll take these connectors out of that foam. So we got to line it up so D13 on this board matches D13 on the THC control board. Looks like we got it right there. That wasn't too bad. All right, snapped right in. Now we'll see what the next steps are. All right, now that I got that THC board in, the directions say to plug the USB into the computer, but do not plug the controller in. Make sure this is unplugged still, which it is, the plug's up here. So I'll plug it into the computer, like that. So the green light comes on around the USB, and the red light on the THC controller is on, which is what's supposed to happen. So that's good. All right, I'm gonna get the cover on and hopefully we'll start cutting something. All right, I'm gonna put the torch head in this V-block holder here. To be honest, I don't know exactly how far it needs to stick out. I'm just gonna put it about halfway, hope we're good. And then I'll adjust it if I need to. I'm just gonna kind of go one side to the other, tighten it, not to put too much pressure on it. That's pretty good. All right, I ran the torch wires and then these stepper motor wires up here, zip tied them in a few places, and then ran them back down that pipe. I've got my first piece of material in here. This is just a scrap piece that I cut out. I got my clamp on. I'm gonna go mix up some water and borax. I heard that that works pretty good to keep the table from rusting. I do have some actual plasma table solution coming, but it's not here. But I'm gonna test with the water and borax because it's a really cheap solution, and I'm kind of nervous that this table's gonna leak somehow. So it'll be a good test. I got my air hose plugged in. I haven't plugged the plasma cutter or the table in yet. I do have the USB plugged in. Boy, I'm nervous. Excited though. All right, I got everything pretty much plugged in and set up. I put some water in the table. I didn't put a ton because I'm not gonna do too much cutting before I get my new cutting fluid. But I did buy this borax to put in the water to hopefully keep things from rusting. So I'm gonna put some of that in here. Just gonna go down every slat and just kind of put a little bit in. I don't know the right amount to put in, but hopefully it can't hurt. This is supposed to be good for keeping it from rusting. It's a good temporary solution, hopefully. This is the Langmuir Systems website. This is the CNC plasma table I bought. It's got a 4-foot by 3-foot table, so not quite a full sheet of steel can fit on it, but that's a pretty big piece. It's advertised for $2,749. So these are all the things that it comes with. I added the $400 torch height controller. I did not get the laptop stand or the limit switch kit. I wanted my laptop a little further away from the table than this because it throws a lot of sparks. I did end up buying the HYPOTHERM 45, but not from the Langmuir website. I actually paid a little bit less for this. I bought mine at Airgas here in Traverse City. But I did end up going with this plasma cutter. As I said, my Lincoln didn't seem to work well with the table. For printable assembly instructions, like I did, you just go to the support tab, go down to Crossfire, Crossfire Pro, or Crossfire XR, whatever model you have, you go to that and hit assembly. And then it's got all the instructions here. But you can also hit print and it'll print it all out. It's a lot of pages, so make sure your printer's all loaded up, and you might want to turn the color printing off. Just do black and white. But these directions are actually really good. They do a really good job of explaining every step, and they got pictures with pretty much every step. It's really nice. I will say, even if you have the instructions printed out, you may want your phone or computer handy, because there's some steps that have helpful videos in it, and those help out a lot, so it's probably a good idea to have either a phone or a computer. So if you run into any issues, there is this forum here, and it's got a lot of information in it. I ended up making an account, but you can just search, whatever you're looking for, and it'll bring up just a lot of different threads, and there's just a ton of helpful information in here, and people are really responsive if you ask questions, so really good setup. All right, as far as software to run the table, you're going to go to support, downloads. Depending on whether you have Windows or Mac, you either download the Fire Control or the Fire Control for Mac. I downloaded the Fire Control 21. It's already on my computer, so I'm not going to download that. But you just run and install that. So what I didn't do is scroll down. I ended up going to the Fusion 360 website to download this, but you can actually scroll down and download Fusion 360, which is a free CAD software. It's actually a really powerful CAD software for free. It is non-commercial, so you can't, use it to start up a shop or anything. If you're going to do production, you got to pay for it, but you get so much for free in Fusion 360. I actually am really impressed by it. So you're going to want to download Fusion 360. You can use other CAD programs. This is just a free one. I also did download this Fusion 360 post processor because it was recommended on the forums. So I downloaded that. I'm not exactly sure what it did, but it was recommended that I did that. So I did that. And then this Fire Control USB THC driver, I ended up needing that. So I just had to download that driver. Okay, this is Fusion 360. It's just a normal general CAD program, but it's got a lot of features for free. So you have your solid modeling, surface, mesh, forming, sheet metal, plastic, and utilities. For most of the stuff I designed for the CNC plasma cutter, I use just solid modeling, sometimes surfacing. I do mesh if I'm 3D scanning something in, but for the most part, just solid modeling. We're gonna be in the design workspace first. So to control the window, you can grab here and it'll allow you to rotate, or you can use your mouse, or I even have a 3D mouse. I do CAD every day and I'm just used to a 3D mouse. So what you can do is just start a sketch. I'll click on the top plane here. Maybe we'll make like a plate with some holes in it. You know, usually you would dimension it out and everything, but I'm just giving an example. We'll extrude 0.125, something like that. So you can design your own plates or anything up like this, but a lot of times you're gonna want like maybe a picture or a part that like mates to another part. So you'll need to insert like a picture or drawing. You can do a canvas, that way you could trace something, or you can insert SVG or DXF, one of those two. So most often I use SVG. So what I do, I go online and I'll find something that I want. So maybe like tire SVG, something like that. And then there's a bunch of options. Etsy has a lot of SVGs that you can buy and they're already done. You just pay just a little bit of money for them, download them, and then you can cut. There's also some websites that you can get the SVGs for free. Those are cool. So you can import those in. The other thing you can do, say we want to make a sign. So I want a Yamaha logo. So I'd like a Yamaha sign. Of course you wouldn't do this because it's a copyrighted thing. So I'll do save image as Yamaha logo. Okay, we'll save that. And then what you can do is go to free SVG converter. It's picsvg.com. It looks like a pretty plain site, but it's actually pretty powerful actually. So I'll upload the picture from our downloads here, Yamaha logo. So uploads, and then you have a couple choices here. I'm gonna go to strong for details. Then you can kind of go through here and see which one gives you the best option. So it looks like internal is doing probably the best so far. Okay, so that one looks pretty good. So I'll download the SVG. So it's gonna download that. We'll go back to Fusion 360, insert it. We'll do insert SVG, insert from computer. I'm guessing it's this top one. We have to pick a plane to put it on. I'm gonna pick the top plane. Okay, so there it is. And you can scale it up or down. You can flip it. You can move it around. So I'll try to center it. I'm not gonna get real critical on dimensions here. Okay, we will finish that sketch. Okay, so that looks good, but we'll say, yeah, for some reason there's two sketches in this. I'll delete this one. I'll open this up, hit edit sketch, and say we're making a sign out of it, something like that. Okay, we'll finish that sketch. Normally I would constrain it and everything, but I'm not going to worry about it. We'll extrude. We'll click on this big open area here, 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 here. This, that. Okay, that looks pretty good. We'll make it an 1/8 inch thick, probably. Okay, so that would be our sign. But as you notice, when it's cut, these are gonna be, you know, falling out. So what we can do is just come over and add some lines here for some tabs that are gonna hold it in. I'm not gonna keep going on that, but, and then you can extrude, do a thin extrude. We'll select these lines, and then it's gonna be negative, so we'll do negative 1/8, and then wall thickness we'll do 0.05, something like that. And instead of cutting, we're gonna join. Okay, there. So we fixed those so they're not floating, but we would have to do it to this one and probably all these and this disc here, but I'm just gonna move on for the sake of time. Okay, now let's say we have it exactly how we want. We're gonna go to manufacture workspace. So now that we're in the manufacturer workspace, we'll go to setup. So it's automatically finding our workpiece here. I'm gonna set the 0 to this corner. It doesn't matter if I click the top or bottom. So that's good. Operation will be cutting. That's all good. I don't want to add any stock. Post-processing, we'll take care of that later. Yes. Okay, now we'll do NC program. We'll name this Yamaha. And then these are my settings that I've currently been using. I just got those offline, or maybe they just showed up in here when I downloaded it, but this is what I've been using. Here you can choose your output folder, so that's where you want your G-code files to export to, and my units are inches, so leave that. Okay, now you want to go to your tool library. So Fusion 360 comes with a lot of preset tools, but I like to make my own and customize it. You get a lot better accuracy that way. So you can go to cutting tools, go to plasma cutter, copy the tool, and then go back to your library and you can paste it, and then you can edit it from here. That's what I've done right here. This is the one I've been using. So you just give it a name, vendor, and then plasma cutter, the units are inches, and then this is the kerf diameter that I measured from a test cut from my plasma cutter. So the more accurate you are with your kerf width, the more accurate your cuts are going to be, because it automatically calculates your cutter compensation. The holder, just plasma cutter head. For 1/8 inch to 3/16 material, I've been using 80 inches per minute. That's been working pretty good for me. Cut height, pierce height, this is what I've been using. I don't remember where I got those numbers, it just seems to work out. And then these, I didn't touch any of this stuff. And then post-processing, I'm not gonna do anything in there. So hit accept. All right, so now we have a new tool added. So now we can go to cutting. So you're gonna choose what you wanna cut. You can pick like the solid, or you can go through and pick all the lines that you wanna cut. You can do it either way. And you can see these arrows. Whatever side this arrow's on is where it's going to calculate the cutter compensation, because there is going to be a little bit of kerf when you cut. So it's either going to go to the inside or outside, and you can tell it which way to go. So we'll select that. Okay, so I think I got everything. And this is neat. You can add tabs automatically, just like we did here. It'll do it in the computer. I'm not very good at it yet. That's why I like to do it manually. But I mean, this is a really good option to automatically do it. These are the settings that I've been using for heights. The tolerance I set to 1 inch, so I have smoother, or not 1 inch, 1,000th, so I have a little bit smoother lines. My compensation, as you can see, the compensation just shows where you're making up for that kerf when you're cutting. So I have it to the left, and then your compensation type has to be in the computer because the fire control system will not let you do your own cutter compensation. It's got to be in computer. And then corners, I like to roll around just to, you know, keep softer edges. Preserve order, it'll cut in the order that you selected things. I don't really care for this one, which order it cuts in. And then smoothing, a lot of times I'll use that, just do 1,000th, about the same as I do for the tolerance. And then in your linking here, you can add a lead-in radius and lead-in angle. That's pretty big for the, this is the lead-in distance, so it's gonna have a line entering your cut. That's pretty big for this. I'll do 20 thousandths. This you probably adjust depending on what size cut you're doing. Lead out's gonna be the same as lead in. Pierce clearance, 80 thousandths. And then you can choose where you want your cuts to start. So say you have a really critical area, you can choose, just say we want to start the Y right here. So we can add points where we want the feature to start cutting. So I think we're all set on there. We've got to grab our plasma cutter, select that. So it has calculated, it's put in our tool head and calculated everything in here, but it is missing this portion here, and I believe it's because it's got really small features in it. So we will edit this. So usually your problem's going to come from this lead-in. You got to really play with this. So I'll do a lead-in of maybe 5 thousandths even. See if that works. It's calculating or generating right now. There we go. Okay, that looks pretty good. Now if we want to watch it cut, we can hit simulate and then play. So you can watch how it's going to be cut. Make sure it's cutting on all the right sides. We'll speed through it. Okay, you can see these areas. If we were saving this, we'd have to switch the arrow around so it's not cutting into the detail that we want to save. So it's guessed that we want to get rid of this detail, which is fine for this. So if you're cutting towards the inside, that means you're probably saving the outside piece. So, all right, that looks good. That's how you start programming it. And then just to get it into a G-code file so you can cut it with the fire control, you go to post-processing. You have to name it again, Yamaha, and then it's just the folder you want it to export to, and then we'll hit post. There we go. So now it has created a G-code file. So now we're gonna have to go to fire control in order to cut our files. I'm not actually going to cut this one because I don't need it or anything. I was just coming up with a quick, simple example that had a few of the things I wanted to show. But in order to use fire control, the CNC table has to be plugged in by USB to your computer. Otherwise, it'll just show up blank. Also, I did have an issue where if you have your computer plugged in, it gives some weird feedback to the CNC machine, and I was getting errors, so I have to run with my computer unplugged. But let's go to fire control and cut our first piece here. All right, this is the fire control CNC program for the table. It's actually made by Langmuir Systems. So you can see you have jog here, so you can use either your keyboard or these controls to jog the head of your plasma cutter to wherever you want. and then you can zero the axes to set that as your work 0. You can do a dry run. That way you can have the plasma cutter head just trace the whatever you're cutting, so you can make sure it fits inside your workpiece. Let me load in our program here. So I'm going to go to the folder where I stored the NC programs. It'll pick up G-code files. Okay, this is the first piece I'm going to cut here. This is a Filthy Knobs Off-Road sign. I'm going to make it out of just some scrap material so I can practice the settings and everything with the machine. This will be the first piece that I run. So if I go to work 0, it's going to go to the center. That's where I set the center point when I was creating my setup in Fusion 360. So my origin's right here. So what I'll do is jog the table until I get to the center of my workpiece and then zero all axes. So it's setting that location as my 0. And then I usually do a dry run and make sure it doesn't go outside of my workpiece. So I've done this already. I'm centered on my plate. So I could adjust a lot of different things here, torch speed, all this stuff, but we already set this when we were programming it and writing the G-code, so I'm not going to mess with anything here. You can see the Crossfire table is connected and it is picking up my THC. So I think everything's good. I'll hit start and we'll run it. First cut. All right, I got the first part cut. This is a sign I wanted to make for my off-road YouTube channel. It looks super good. In hindsight, I probably wouldn't have done the jagged letters because I really wanted to see how straight and clean it cuts. I mean, you can see on the outside that it's really straight and clean, but just the font I used is really wiggly. But I mean, it looks exactly like I designed it. I mean, this thing is awesome. I need a little bit more practice with it just to get all the settings right and everything. It seemed to be good right off the bat. It sprays up a ton of water. I'm not really sure, maybe with more water it wouldn't, but that doesn't make much sense either. I don't know. It sprays up a ton of water. Maybe I'm using too much power. I gotta play around with it, figure it out. I can't believe how dirty this water is already. I guess it's always just gonna look nasty. I don't know. It hurts so bad seeing the slats cut up like that. I know that's what they're for, but it's a brand new table. Oh well, lots more cuts coming. So, man, I'm so happy with it. This thing worked great. All right, this is the sign all finished up. I just threw some white board in the back of it just so you could, you know, kind of see the lettering. But man, it does a really good job. But yeah, my new press brake did a sweet job. I'm just, you know, getting really excited about this whole shop setup. I definitely need to clean my shop since I've been working on everything, but yeah, it was a good time. The cuts seem to be really accurate. I'm learning the, you know, cutter compensation and everything, and you know, I'm used to doing that on mills, but this is all in the computer, and a lot of it is getting the, you know, kerf or orifice of the plasma tip, just figuring out how wide that is, and the more accurate you are on the width of your you know, cutting kerf, the more accurate your cuts are going to be. So I think I got it pretty well dialed in. I've tried to scratch up the powder coating. It's so strong. I really have been enjoying powder coating stuff as well. This has got my fingerprints all over it, but yeah. There were a few obstacles that I ran into getting this plasma table going. One is the THC, the torch height controller. when I installed that, it just kept saying some error about the THC. But then I read on the Langmuir forum that there's a button on the THC you can hit and it'll reset it. And after that, it worked perfectly. But just so you know, there is a button on the THC you can hit if you have an error code that pops up. Another issue that I ran into was the plasma cutter kept cutting out and then shutting the program down. And I struggled with this for quite a long time, actually. And I found that the crimp connectors that Langmuir supplies, those blue ones that I attached, those were not getting a good connection at all. Like, I tried to squeeze them down and it just still, every once in a while it would kick off. So I ended up actually soldering the wires in, so I knew it had a good connection, and I haven't had any problems after that. Another thing that I ran into was I had to download and update a driver for the torch height controller. That was one thing that the instructions didn't really mention, or it wasn't very clear, but I found that on the forum as well. So there is a driver that you have to update or download, depending on if you downloaded it originally or not. The last thing that I ran into that I knew was probably going to be an issue is the water table leaks. It's really annoying. I knew it was going to be an issue when I was sealing it up. I was like, man, there's no way that this is going to stay sealed. It's going to drip at least a little bit. When you have two water containers and try to pinch them together and have water overflow on the sides, it's just not a good idea. I see why they did it, to save on packaging, but that water pan is just junk. I'm going to have a new one made out of stainless steel, just a solid water pan that's not going to leak. I'm going to get the drains put into it, but that's just, you know, another thing that I got to add. I'll show you what the table looks like. I've done quite a bit of cutting on it, and it looks nasty already. But luckily I got new cutting fluid that I'm going to put in, and I'm going to clean the table up, but just a warning, it's pretty rough. All right, so here's the water table. There's so much like metal pieces in here, which is expected, but absolutely no water. I mean, there's a little leftover, but it all leaked out. I mean, it evaporated as well, but yeah, that seam is just junk. But don't get me wrong, I'm really happy with the table. This could have been a lot better. I really don't like pushing people to subscribe to the channel, because I feel like if they like the content, they'll subscribe anyway because they want to see more. But we're at 1.97 thousand subscribers. We'd really like to hit 2,000 soon. So if you guys end up liking this video, please consider subscribing to the channel. It really helps us out. All right, that's it. I apologize that the video was so long. I tried to compress it as much as I could, but I wanted to put everything in one video. I didn't want to do like a part one assembly, running the thing, and then the software, all that stuff. I wanted to give you guys all the information in one video, so it, you know, might help somebody out. You can skip through, find what you need. If you watched the entire video, I mean, I'm impressed. It was long, I'm monotone. You know, assembling stuff is boring, and just walking through instructions is really tedious and time consuming. So I appreciate you watching this video. If this is your first time on the channel, we have a lot of side-by-side content, off-road content, quads, snowmobiles, just a lot of off-road stuff. I've been buying a lot of fabrication equipment. I'm guessing I'm gonna do a few more reviews. I bought a press brake that I really like. The powder coating gun, I'd like to do some reviews. I know a lot of guys that have side-by-sides, you know, like to work on their stuff, make parts for it. So it might be something that everyone's interested in. And so if you're interested in anything off-road or fabrication-wise, or just, you know, whatever I'm working on, you know, go through, check out some of our other videos, and subscribe if you like what you see. Thanks for watching. See you next time. All right, now it's a time.